First of all, thank you for giving me this opportunity, to be part of the third international conference, the AI and machine learning applications. Actually today again I present one of the my research papers that is done during my journey in PhD program. So before I start, just I'd like just to define sentiment analysis. What does it mean, sentiment analysis? It's an approach uses for both NLP, natural language processing, plus machine learning algorithms to extract or mine people's feelings, opinions from different contents. Contents it could be related to products or person, service, events, any idea, which the main purpose just to detect the feeling, either it's positive or negative or maybe neutral. Why, should we study the sentiment analysis? It helps the business to analyze people's opinion, improving customer service. And definitely, it's gonna saving, not even the saving the time, the money, because, we are targeting products and we really care about customers' opinions, customers' ideas, and how can we know their ideas? How can we know if they are happy or they are not happy with our service? By analyzing their feelings or their opinions. So sentiment analysis, it can give at the end is gonna help the decision makers and their decisions in case they want to increase the products, or they want to maybe they want to issue some rules, so they care about the people's opinions. Sentiment analysis, why we really care about sentiment analysis during COVID-19. Why? So because social media, especially, actually we focus on Twitters in this research, because, we know that Twitters as one of the most familiar in the social media, around the world. We have like too many people, they are really dependent that Twitters and sending their communications between their friends or between their families. So social media interaction have increased with people's posts, and definitely they reflect their feelings and motivations toward the COVID-19 pandemic and its impact on their health and economic state. During the pandemic, some people expressed their experiences and their panic when they got sick, while others expressed their opinions toward having the vaccinations. Actually, this is really the most important, just to know, just to mind their feeling during the vaccination. The fear that time that the people, they are really worried about the vaccination, and definitely the decision maker, they want to know these feelings. So many politicians and decision makers from different positions share their perspectives toward the procedures and the precautions and during these pandemics. The purpose of this study is proposing the chatbot for evaluating the sentiment analysis by using machine learning algorithms. Evaluating, we focus on two basic algorithms from support learning and support vector machines and the naive Bayes algorithm. At the end, we compared both algorithms together based on the accuracy of the both classifier, computing the difference of the accuracy, and based on, we added some features, and besides of that, we changed about the test split ratios for both classifiers in order to know if there is any role of the ratios in the accuracy. The framework Power Chatbot is, it's basically compared from the three main parts, which is the NLP functions for the pre-processing the text, and the generator, or this is that's the algorithms or the classifiers, And we have the knowledge base, which we depend on the tweets from the Kaggle platform. We got like 4157 tweets, and it's all labeled. Here we can see more about these things after this slide. Before we go just to the methodology here, just I want here to expose some of the related work about using the classifiers of the basically of the sentiment analysis. You see here about, we have like here like 6, 7 here research papers, and it's like the majority are the Twitter here, if you can see here the Twitters, but the sentiment analysis here, the tools of the approach, some of them they use different algorithms. It's like there is either they use the BERT or logistic regressions, as well as the Markov model. So we can see here different models. And there is like a few researchers here, they use the YouTube from the YouTube channels. They can transcribe some of the interviews, some of the videos, whatever, so they can get some feelings and opinions from the people. The methodology here, I classified here, as you can see, like 1, 2, 3, 4, 5 here phases. Before I can go over all of these phases here, the platform we use here, Anaconda platform, and basically the Jupyter notebook. And we use different packages like scikit and pandas and LTK from the Python. Let's start with the data collections here. Okay, the data collection here we use as what I have mentioned before that, the tweets corpus. And here as, we can see here like 4157 tweets from the Kaggle's website, and all is in the format CSV. And basically all these tweets have been collected during the pandemic. It's like between 20 to 21. And all labeled based on the feeling itself. We can see some people that can feel extremely positive, other positive, negative, so it depends to the feeling. Let's see here, after we collect all of this data, before going to the training this data, we have to pre-process the data and cleaning the data. First, we clean the data, then we started with the entire processes, as we can see here, like, lower casing. We use some functions to lowercase all the text, removing any punctuations in order, the main purpose about pre-processing to convert the words or the tokens into tokens to be understandable by machine learning. So, and then we remove the stopping words like the, and, all these stopping words that, usually it's repeated and it's gonna be confused when we learn the machine learning with these words. After that, we before the tokenization, we stemming the words that we return it to the roots of the, for example, recovering. Recovering. We remove or we simplify the words to the stem words like recover, and as well as this is the entire processes here. This is called data pre-processing. And then we convert it into tokenized, we tokenize it into tokens, understandables to the machine learning. And then, we have to vectorize all these the tokens into numbers. Feature extractions here, we use in the function, the transformer, df. This is the term frequency for weighting the words in order to convert these tokens into numbers. So we use the term frequency, it's like how many words is like, the same word repeated here, how many times. This is called term frequency. It's in the same sentence. And then we have to know the same particular word, how many times repeated in the entire document, or this is exactly what's called, this is what we call it, TF-IDF transformer. So we have to multiply both numbers together. This TF, calculates the number of times that these features or this token is repeated into the sentence, and then it represents the importance of the word, because we know the same sentence, there is some words is repeated more than one time. That means this is an important, so we have a high weight for this word. It indicates the importance of this word, and the IDF is calculates the number of sentences that have this particular word or this particular feature. And then we can multiply both numbers together to get the transformer. After that, afterward, we have the tokens, the texts are ready to train it into the algorithms or into the classifiers. So we have, from the supervised learning, we have like two algorithms, naive-Bayes algorithm and support vector machine. Just here, I want to give in simple words, just to define or to explain the difference between both algorithms. Naive-Bayes, actually in the next year, I can here, yes, here. The naive-Bayes algorithm, it's basically, it's the Bayes theory, it's probabilities. For example, I can give you example. For example, here the words that I have it in one of the Twitters. I'm excited for recovering. This is all the words that mentions 3, 4 sentences, as we can see in the right side. This is the tweet here, 1, 3 or 4 sentences from the corpus. Here, I have 2 positive tweets. I have 2 negative tweets and others, but here I did not mention. I mentioned only 4 tweets here. So what we have. How can we calculate it in the naive-Bayes algorithm? How it works basically by, this is all the words here. I am excited, the positive. Based on the labeling here, the corpus, we can calculate how many words are positive, how many words are tagged or labeled as negative. And then we can calculate here the probabilities that for recovering, for example, it's 1 out of 9, because we have only one word, it's out of 9 from positive words. And again, we have to time how many positive out of all the corpus. Again, the recovering out of all the corpus, and we can multiply it together. And then we can get here the probability that recovering is a positive word. Okay. Let's go here next to the support vector machine. Support vector machine is different. It's based on the regression analysis, and it works for the classification as well. It's an algorithm creates a line. It's as we can see here, hyperplane, which separate the data into classes. For example, here we have 2 classes in our example. We have happy, sad, for example, or positive, negative. This separator between the categories is found in the data are transferred in such way that the separator could be drawn as a hyperplane. Following these characteristics of new data can be used to predict the group to which new record should belong. After the transformation, the boundary between the 2 categories can be defined as a hyperplane. We can tell that this group or this, we see this dot, it represents the items or the features itself. So here it's we have sometimes, we have 3 dimensions, 3 groups, it's based on the classifications. Okay, so this is here the difference, it's here is more than regression analysis, regression classifiers based on the other side, or the naive-Bayes algorithm is based more in the is probabilities. Now let's testing the model here. The results here after testing the model, before we test the model here for the training and the test ratio, here we divided the test ratio, we took first part only 10%, the next when we try it next in the next phase, we used 20% and then 30%. And these here the classifier as you can see here. Like the first we have naive Bayes and we have the support vector machine. And after we testing the model here, as you can see, the high performance, when we split it in 10%, let's focus in naive Bayes, it's like 37. When we make it 20%, it's 36, and here then 35. And it's can see before that the high performance in the support vector machine model accuracy comparing to the naive Bayes model in the general. But when we decrease the distance split ratio, there is an intended to be more accurate, as we can see in the naive Bayes. But in general, as we can see, support vector machine it's outperform than the naive Bayes classifier. Okay, the study here reveals that training speed here, when we try it here for both classifiers, there's extremely slow the support vector machine comparing with the naive Bayes. If you can see here, it took, just when we test it, it's really accurate. It's really accurate. The accuracy it's reached like 97% compared to the naive Bayes, which is not exceeding 50%. However, the speed is relatively slow comparing to the naive Bayes classifier. You can see it took like 40 minutes here, and again it's like from 35 minutes to 40 minutes comparing to the naive Bayes like 3 minutes, 2 minutes, and 2 minutes, even if we split the ratio like 30% in the test set. So this is here actually, we have actually here, we can see what we're gonna have in our recommendation, or, or in the future work. Actually, we have to work more, just to find out that it might be with the processor or just to speed it up for running the support vector machine. Here, just when we tried that chatbot, I said, I like working from home. It's like during the COVID, it can tell you exactly what you feel. And again, I feel sick here. I have fevers, like you are feeling negative. And this is here during the trying the chatbot in the lab. Let's go to the conclusions here. You see here the literature that high performance in the support vector machine model, the accuracy comparing with the naive Bayes model, as what we just saw like in a minute, the accuracy of the model increased when decreasing the test split ratio. And the study revealed as well that training speed varied in both models, and the speed of support vector machine classifier is extremely slow, even though it's more accurate classifier. So that's what we have to consider it. Actually, support vector machine, I would really, I like it, to use it and to do more testing on the support vector machine. I'll try to use another processor actually to the maybe I'll go to the different computer and I can try it. It might work much better. The future studies here, in this study we worked with support vector machine and naive Bayes algorithms. In the future work, we're gonna start with the deep learning, CNN and RNN. And now I'm in the middle of this thing, I'm working in the deep learning, and in a couple of months we're gonna see another results, and definitely we're gonna see it in publication later, or we're gonna present it in the conference. We'll try to improve our algorithm by studying the role of particular features that could improve the speed of the support vector machine classifier without affecting the accuracy of the predictions, because we like the accuracy in the support vector machine, but it's really extremely slow. This study focused on chatbot that understanding English tweets. In the future, we will improve it by including other languages such as Arabic language. Yeah, to be honest, when we started with this research, we tried to get or to find Arabic tweets, in different resources because, even though, we collected some tweets, it's like, but it's not enough comparing with the English tweets, as you see, like we exceeded 40,000 tweets. Comparing with the Arabic, it's like, it's like hundreds. So that's why we started with the English, and later on, definitely we're gonna go with the Arabic. By the way, this is only we are here focused in this domain as, COVID, but definitely the same, the same classifiers, we can apply it in other domains, education, students, either service, supporting service to the students, or, we might go to the any products for marketing industry. So it's gonna be applied either, different domains, or we can go with the same domain to the different architecture or classifier. So we're gonna work in these things in the future. Actually, thank you very much. Thank you. That's it. Thank you.